Hello, my dear friends. Welcome to this discussion. We are going to be doing a number in embedded systems, and this number pertains the traffic light controller. So you have been hired as an embedded systems engineer to develop a traffic light control system using Arduino. Task: write down the code for the traffic lights controller. Use 3 LEDs with the following sequence. Red is on for 15 seconds, and yellow is on for 5 seconds. Green is on for 20 seconds. Ensure that only one light is on at a time, and the cycle repeats continuously. So what do you think about we need to do here? First of all, we are going to go to our Arduino and make sure that we have only red on for 15 seconds. The moment it finishes, we go to yellow. So red is on, some vehicles are moving, others are stationary. Then the moment 15 seconds elapse, then we switch on to the yellow light for about 5 seconds, and then we go to green. So let's look at the solution. This is the design. We are saying if we consider this junction of the road, we have some vehicles moving, others stationary. So for example, if we take vehicles in this direction moving, we will have to have a stop here. So this will be in red, this one will be in red, and we shall have a green along here. So the moment the green elapses, we go back to red. Okay, we go back to red. So red is on. Obviously, we will find that the moment red goes on, we stop and switch on to the other line. So this is just a basic one really, because in the more advanced systems, obviously we would be having many lights. Obviously, like here, we'll have a light here, lights here, lights here, and all those have to be designed properly so that they work in synchronous. So that is basically what we want to implement. So what do we need? We need the LEDs, the requirements. Let me first take us through the requirements. So the components that we shall need, probably may need a breadboard, maybe one piece, a bigger one. Then if they are the small ones, you may need 2 pieces, or just 1 piece may be enough according to our basic program. Then resistors to limit the flow of current from the Arduino board. Okay, so we shall use a 220 ohms, and we are going to have 3 pieces because we have 3 LEDs. You need also to put 3 LEDs. 2, you need an Arduino IDE, a computer, you need an Arduino board, you need a multimeter to measure whether current is reaching in some points, and for troubleshooting, you need a jumper wire, you need the CAD software, for example, freezing, or Proteus for you to design the schematic. And then after simulation, you can take it to the board. Then the block diagram, you need to show how your components are communicating. And for example, you have the breadboard with the LED, you have the microcontroller unit. So you have inputs and outputs. But basically here we are looking at the outputs, and the logic that gives outputs is written on the microcontroller. So you will have a computer here for writing the program, and then you take it to the microcontroller unit, and then you have outputs from the microcontroller unit, which are going to be the lights or LEDs. Then you need to write a block diagram, a flow chart that is starting, you read, you go through a number of processes up to stop. So that is basically the components that you need. So we are doing that so that in any case, if this comes into, if it comes within an examination, you should be able to know the marks they have given. If they have given you a lot of marks, like 20 or 25, you can look at how you need to divide your answers, because the code alone may not be enough to give you all the marks. So let's write the code now. So first of all, we know that when we go to Arduino, we have two main important blocks. That's the void setup and the void loop. The void setup is the block where things run once. And the void loop is where things run repeatedly and continuously. So for that matter, we are going to first define the variables. So where are we going to be connecting our lights or LEDs? So we create a variable for red LED. So we are using a constant int. Red LED is assigned 5, meaning we want to connect it to pin number 5. We are just storing 5 in this variable for easy readability, so that as a person goes down there, the code is becoming lengthy, he knows what he is doing. So const, we are saying if we connect it to pin number 5, there is no other processes that are going to be using that pin number 5. So that's what the word const means. It specifies only and only this activity for this pin. No other activity or process is going to utilize that pin. Okay, because someone can make a mistake and instead of connecting red to 5, he connects it to 7. So all of these are going to help us do what? Are going to help us keep steady and not confuse the pins. So next is that we have the yellow LED, we have the green LED, and we are using int because the pin numbers are always integers. We don't have something like pin number 2.0, nothing. It is just pin number 2, pin number 0, pin number 1, pin number 8. So we are using 5, 7, and 8 as our pins. Digital pins, please. These are digital pins. So void setup, we are going to now declare what is going to be an output, what is going to be an input. So remember to put comments. So here we are defining the pins to use, and we are using the digital pins 5, 7, 8. This is a commented line. So we go to pin mode, red LED output. Always you put the variable name here, or you just write your pin number, and then you're declaring it as either input or output. That is what the pin mode does. So you put the pin number here. This is 5, comma, output, and output is in capital letters. Then we terminate. So we are declaring pin 5 as output. The same thing with this pin. This is 7 also as output. This is 8 as output. And then it is a good practice to always start, before you power the system, we have to make sure that everything is okay. By okay, I mean the system must be safe. Even when we power it at the beginning, it should start from 0. So we are saying digitalWrite on pin number 5, where there is a red LED connected, set it to low. The yellow LED, set it to low. The green LED, set it to low. Then we close with a curly bracket. Remember, there is a curly bracket here for opening and the curly bracket here for closing. So this code in void setup is going to run once. We continue. Let's go to void loop. So this is where now the logic is going to work for us in switching on red, switching on yellow, and so on and so forth. So we are starting here, digitalWrite, red LED, we are setting it high. because we were told that set red high first for 15 seconds. So digitalWrite yellow LED, we are setting it low. digitalWrite green LED, we are setting it low, and have a delay for 15 seconds. So as red is on, some vehicles are stationary, others are moving. Now from red, we are saying go to, from red, we are saying go to yellow. So digitalWrite red LED, we are setting it low now. You check, the difference here is only red is high, only yellow is high here, and only green is high here. So you have a delay of 5 seconds, yellow on, then you digitalWrite red LED low, digitalWrite yellow LED low, and digitalWrite green LED high. Then the green is on for 20 seconds. That's what they said. If there was another sequence added or another step added, because in practical systems, you'll find that after the green has gone high, you have again yellow switching. So we would have put here a yellow on for 5 seconds again, but it is not what? It is not given as in instructions, but that's what we should have put. We would just copy and paste this code at the end. Okay? Then remember to put comments. Yes, remember to put comments so that you make your code understandable and readable. So let's go to our simulator and then be able to do what? Be able to simulate this problem. So I'm going to be using Tinkercad. It's a good and user-friendly interface or environment for us to simulate simple circuits. So in here we have gone to Google and typed in Tinkercad. So in Tinkercad, we are just going to go to Tinker. We go to circuits. So we start tinkering. So we are going to create our own and sign in with Google. So give it some time. So the moment we reach in this environment, we click create. So we create 3 design code blocks or circuits. We want circuits. My computer is loaded, so it's a little bit slower. Yeah, if you have a super faster computer, it would be loading this very fast. So the traffic light is the one that we are going to implement very fast because we can just write, I think, one code and then copy and paste and edit. So first of all, we need an Arduino board. So it's here. That's our Arduino board. We need, to work with Arduino board efficiently, since we have LEDs, we are going to be calling in the resistors, and the resistors that we need that can work efficiently with the LEDs. We can either use a 220 or a 330. So let's use a 220 ohm resistor. We copy, paste, we paste. We have a LED. We want it. We want a red one. Yes. We copy and paste another one. Then we just change this to yellow. We change this to green. Okay. What else do we need? This is going to be a very simple scenario. So we just need to know which one is anode, which one is cathode. So we are going to be mirroring these LEDs. so that we turn the anode to the side of the board, since they are the ones that are going to be receiving lines of code, lines of signal from the board. The next one is to determine, we are going to determine the pins. We said these pin numbers are going to be number what? We said which one? 5, 7, and 8. So we are going to use 5. So that is 1. We have 7. Then the other one is 8. So the rest is connected to the resistors. The rest of the pins are connected to their respective resistors. And what else? We then have to connect them to the ground of the board. So I'm going to say this is the ground. We just pick one ground, either here or there. Let's pick from this side. And then we just connect this here. We connect that there. So now they are connected to the ground. So remember, this is a programmable circuit. So we just have to go to where we just need to find where to write the code. So we come here, we click on code. So going to code, we either use blocks. I don't like using blocks. I like using the text. Another one can use blocks and text, but me, I'll use only text. So the moment you open it, you'll find a default code here. So what we do, we just have to do what? Obviously, whatever you see here is this is the red built-in as output. So this is always pin number 13. The moment you have anything connected here, let us assume we have. Let me just do that for the sake of us understanding what this is saying. So we are going to run this code, and you will see it has even is using a lot of power, and therefore the board has crashed. The board has been burnt. So what we can do is to just add a resistor. So we stop, we add a resistor. So this is going to go to the ground. So the moment we run this, it won't burn the board. So you can see pin number 13 is always the inbuilt pin. I mean, is the one connected to the inbuilt LED. So always when you connect anything to pin 13, you always see that this internal LED is also lighting the moment that pin is set high. So let's stop that and do ours. So we are here. We are just going to remove that and say red. Let's call it a red light. And we are setting it as out. We just copy and paste here, copy and paste there. Then we say this is yellow light. This is green light. But remember, we haven't defined these variables. So what we do, we just go up and say const int red light is equal to, we said that red is connected to number 8. Then we terminate. We just copy this. We copy this. We copy that and paste. We copy and paste there. Then we add. This is yellow light. Remember, we have this as green light, and the pin for green is 5. This is 5, and the other one is 7. So the moment we're done there, so another person actually could also say hash define. So when you find such a code, you just don't think it's something different. Someone can say hash define red light, and then he says this is 8, and he doesn't need it to terminate. So, but this is a different way of declaring that this variable is for pin. Now, good. So once we are done here, we said it's a good practice to start this when it is at digitalWrite. This is going to be red light. We say the low, and then we just copy. It is here. So this is supposed to be yellow light. Remember to keep the spellings. This is green light. Okay, so we are done with the void setup. We go to void loop. So instead of the red built in, we are going to use red light. So let's copy and paste. We copy and paste that. Remember, we said the delay is for 15 seconds. So we comment here and say this is for 1500 milliseconds. And this is going to be high. This is going to be low. This is going to also be, this is low. But this is green. Then this is green. Now what I do, I just copy this and then do what? Paste that. So this one, I'm deleting it, and also delete this. Add, this was a red. We are putting something here. This is supposed to be 20,000. This is supposed to be 5,000, and this yellow is supposed to be. And then what is supposed to be high is green here. The moment we are done, we close the curly bracket for void loop, and then go through our code. We compile. So this one uses an internal compiler. It has a compiler in itself. So the moment we start simulation, it will just compile and then detect errors. This is small. So, so sorry, the const is supposed to begin with the small c. So, what we had earlier on said, please go back and make sure that you change that c to be small. So you can see now it is running because it has compiled. So start the simulation. So check. For 15, it switches to yellow. 2. So 5, it hasn't counted the 5 that we want. So we go back and check for green. I mean for yellow. Yellow is supposed to be 5. So you can see. So these are supposed to be 5,000 milliseconds. So we started the simulation and compile again. Yes, please.
Where we have digitalWrite, like for yellow, digitalWrite for yellow, and still rate is still high. Won't it affect our simulation?
It will. Let's go back and see. For yellow, this is green. This is supposed to be green, so yeah. So this will be supposed to be low. Yeah.
Low.
Yeah. Wonderful.
Yeah, that is it.
Yeah, so that is the challenge with so it finishes 15 seconds, switches to yellow, and people start. Okay, 20, so it starts when it reaches 30 watt. It's supposed to be now 40. The moment it reaches 40, it will go back. So let's wait and see if it goes back at red. You can see. So it executes continuously as long as the other conditions set are true and the lines are written within what? The lines must be written within. Okay, so I think if there are no questions, allow me to invite Engineer Brazius to take us through a few things here and there before we